Okay, look at the molecular weight distribution curve. Okay, for narrow curve contain molecular weight that are nearly the same in molecular weight. And for narrow curve, this is the narrow. It has a high molecular weight, better processing at high temperature. And the second one is the broad. Broad, a broader range of chain length from short to long. So resin with this type of distribution have good environmental stress, crack resistant, good impact resistant, and good processability. Okay, however, all synthetic polymer are polydispersed in that they contain polymer chains of unequal length. And so the molecular weight is not a single value. The polymer exists as a distribution of chain length and molecular weight. So the molecular weight of a polymer must therefore be described as some average molecular weight calculated from the molecular weight of all the chain in the sample. Okay, there are many ways to measure molecular weight. Examples include osmometry, centrifugation, and batch light scattering. Each of these methodologies give a single measurement and average molecular weight. For example, MW measured by light scattering, osmometry measure Mn, and centrifugation measure the Mz. So although this kind of method give you a molecular weight, they do not describe a distribution. So we use a GPC, or also known as size exclusion chromatography, to measure the molecular weight. So the advantages of GPC, that is a separation technique, and as such it is the only common technique that allows the measurement of the molecular weight distribution, not just a single average value. So this is the instrument of GPC, and the principle, it used a mobile phase, okay, which is the solvent, and this is the system. First, this solvent, the mobile phase, it will injected through the solvent delivery system, okay, by using an injector. Okay, so sample also will be injected into the injector, and this sample, it will move into the column. So the separation will occur in the column, and this column contains very tiny particles of silica beads. So along the way from starting here to here, all the compound to be separated or to be measured is separated in this column and will be detected as this curve in the data system. So we can measure whether the polymer has narrow or broad, and also together with the Mn, Mz, and Mw, and also the PDI value. Okay. So this is the gel bits in the column. It have pores in them of a defined size range, which allow smaller molecules to enter but exclude molecules larger than the pore diameter. So it used a 5 micrometer microporous polystyrene beads. Okay, so it used the types of packed column. Alright, it has two types of column for chromatography, whether either packed or capillary column. For GPC, we use packed column. So this is the illustration for packed column. Okay, polymer solution pumped at a constant flow rate, and by the time increase, molecules smaller than gel bead pores, and this is the bigger molecule, so it will detect only the small molecule. Okay, this one is the collector flask, solvent reservoir, sample injection, and inside this is a column, and this is the detector. So for size segregation chromatography, yes, we can see the red arrow represent the large molecule, and the blue one is small molecule, and the larger molecule will elute first. Okay, look at the curve here. A is the injection time. Okay, injection time where when the material is start to be injected, it will pass into the column. And this is the illustration for the injection, which is the beginning of the process. Okay, solvent is injected. Solvent flow is injected into the column, and the solvent together with the sample will penetrate or will flow through the porous packing bits, silica bits. Okay, and then B is the size of separation. The bigger one is the larger molecule, and the smaller is the small molecule. And the bigger molecule will be eluted first. Okay, will come out first from the column. Okay, so the solvent together with the sample, after detected, it will be collected in the collector flask in form of liquid. And C is the curve for larger solute. Okay, this is curve for large molecule, and this one is a curve for small molecule. Means that small molecule will be eluted last, and this is the retention time or volume, and it is represented by RT. So the physical properties of polymer are also related to their molecular weight. For example, higher molecular weight will increase the tensile strength. So the explanation behind this in terms of molecular chain is higher molecular weight will implies higher entanglement molecular chain, which is wrapping of polymer chains around each other. So when the molecular coil portion of chain will be straightened out until it reach elongation at break, which is the tensile strength at break. It also will impact the impact strength. Okay, higher molecular weight will produce higher impact strength. So this is the exercise you need to do. Please calculate what is the value for Mn, Mw, and Mwd. Okay, and then I want you to draw the PDI curve. Okay, so you need to measure Mw over Mn in order for you to measure PDI. Okay, so make sure you draw the curve. You mark where is the Mn and where is Mw point. You need to make a table like this. Okay, so if the question didn't give an I value, but it will give a Wi value, which is weight initial. So you can use this formula. Okay, if the question directly give an I value, for example, in this question, it give an I value. So you just copy down this value into next table. Okay, also mi is given, mi and ni is given. So you just fill in this column, just times ni with mi. So you will get the value mi here, and don't forget to sum up. Okay, and this one mi square. Okay, so yang ni untuk value mi sahaja awak kuasakan, ni tak payah. Okay, so you will get the total of mi square, and then you can calculate mn and mw and together with pwi. Okay, so this is your exercise, and please submit to me through WhatsApp after you finish make the calculation. Thank you.